Oh yeah, sorry, Sophia.
Go.
All right, perfect. Now we're recording. All right. So to kind of start off is like defining what is a pure substance and like a heterogeneous mixture. So basically out of this list, so we have A, B, C, and D. We have sugar water, ocean water, propane gas, and then just air in the atmosphere. So I'm just gonna just put air. So just covering your bases. Which of these, like out of all of these options, which one of these is a pure substance? Meaning it's the only thing in it's the only molecule ever within a substance or like within its sample.
Propane gas.
Yeah, propane gas because it's specifically saying that it's just propane molecules within just the gas because remember sugar water, it's obviously you have sugar and water mixed together. Same thing with the ocean water, you have salt and whatever else will be left behind there. And then air is just like a mixture of oxygen, nitrogen, hydrogen, all sorts of gas molecules. So yeah, propane gas. I know it's gonna be again like I know it's tedious, but the basics, but it's very important to get that down. So
If anybody's
uh
lost, we're on page 295 of your work.
mhm. Yeah, it's at the top it should say first semester review. So we're just gonna be going through it, covering our basics as we get more and more through the modules. So let's see. All right. So we're on number 2 right now. If everyone's confused. So it's asking us, so which of the following is a chemical property of sodium? So I'm just gonna put chemical property of Na, sodium. So the options we have is that the molar mass. So I'm just gonna put MM for short. That's molar mass is 22.99 grams per mole. Then for B, we have it's soft, silvery. I know I have very bad handwriting, and it's a white metal. Then for C, we're given that the density is 0.968 grams per centimeter cubed at room temperature. So I'm just gonna do this for short at 25 degrees Celsius. That's room temperature for short. And then we have that it's in its elemental form, it's highly reactive. So who can tell me which of these is a chemical property and not a physical property?
Is it D?
Sorry, can you repeat that?
Is it D, the highly reactive?
And why do you think it's D?
Because the other ones are physical properties, I think.
Yeah, exactly, because the mass, that's like we're looking at its physical weight, right? Along with like the
Oh man,
softs. Oh, sorry, can someone say something?
my bad.
Uh, that's okay. And then again, the soft silvery white metal, we're just physically describing it. Density is another physical property, just seeing like how like dense it is. And the highly reactivity, because obviously chemically everything's just we're looking at things how they react, basically. It's like a little shorthand way of thinking of it. But yeah, so it would be D, highly reactive. So going on to number 4, I believe, was number 3, my bad, which is like our units and our SI units and how to convert them, right? So it's saying that we're given 43.5 grams of bromine, and it's ask us for the volume. However, we don't have a scale for that, but we do know the density. That's the question saying. So the density for, let me fix that. The density for bromine, we know it's equal to 3.1028 grams per milliliters. So how can I find the volume first of all? Remember, this is where we're converting our units, so like we're canceling stuff out. So who can tell me how I can find the volume from this mass given density?
We would cancel the grams by
dividing the 43.5 grams by 3.1028 from the density?
Let's try it out. So here we have 3.1028 grams. And remember your dimensional analysis table here, where whatever units that's technically is a top unit is a bottom unit. So our mLs will kind of be down here. And you say by dividing it, right? So let's see here. So we will technically put our 43.5 grams here, right? So when we were to, if we were to just cancel these two out, but if you notice, if we were to cancel these out, we'd be left with a number and then 1 over milliliters, because milliliters still places as a denominator. So I get what you're trying to say, but let's do this, where remember, whatever unit you're trying to cancel, or I should be more specific, where if you see a unit like this, where it's like a unit over another one, you would want to put that in the series, like next to your initial unit. So here we have our 43.5 grams. And then since you say we want to cancel out grams, right? So the only way we could do that is by putting grams at the bottom. So here, in this case, it's 1 milliliter at the top with our 3.1028 grams at the bottom. Our grams would cancel out. And then what number would that give me? Because remember, now we would just multiply by the top and divide by the bottom.
Be 14.0
Yeah, be 14.0. And what units do I have left?
milliliters.
Milliliters, yeah, correct. Because remember, units are very important, because you can't just like, I mean, at first we let it slide that you just put the number because you were only working with like 1 or 2 units, but now that you guys know more from the semester, it's very important to label your units specifically. That way you're not lost in any way. Let's see.
If anybody's lost, we're on page 295 of the workbook. We're doing the
Yes.
100 question review in the back. Also, rule of thumb for dimensional analysis, it's always a good idea to always write down first what's given in the problem so that you come out with the right units.
Yeah, it's like what you're given and what you're looking for. That way you know what to do.
Especially when you're using density. I know that's not something that like we cover in depth, but just picture your density as a conversion factor. So just like you've been working with conversion factors the rest of the semester with other units, just picture density, the conversion factor from grams to milliliters.
Let's see, I'm looking over number 4. Let's see, so okay, so you have a 10 milliliter graduate cylinder that has marks to the 10th of a milliliter to measure the volume of liquid. That's just describing the low measuring cup. Of the amount you measured, which of the following would be an accurate measurement to record? Okay, so it's saying that, so a graduate cylinder, we have a 10 milliliter graduate cylinder, which if you don't know, it's this little like tubing thing. I know I shouldn't say thing. It's like I don't know, in your labs, it covers like this long measuring tube where since it's saying 10 milliliter by every 10th, it marks 10 milliliters. And it's asking you like which of these values is closer to be more accurate to. So we have 5 milliliters, 5.4 milliliters, 5.40 milliliters, and then 5.405 milliliters. So it's asking you if which of these measurements would be more accurate in terms of if you were to say read a liquid that was like somewhere, given these numbers, it would be roughly like at around here. So yeah, so it's your 10th of a milliliter. So like which of these would be more accurate to be reading? I believe that's what the question's asking.
Keeping in mind also that they're telling you that the graduated cylinder has marks to the 10th of a milliliter. So think tenths in terms of decimal.
So like all these little marks and then like a bigger mark to indicate the 10th, the 10th milliliter. Let's see. B. see. It was every 10th of a milliliter. Um, hmm. Can you help me out, guys? Like Sophia and Brittany, because it's like one of more conceptual ones. Like,
Yeah.
I
Just
I-
the reason for this one, it says beyond it, because again, the question is mentioning that the graduated cylinder measures by 10th of a milliliter. So you have to go through your answers and see which one is given to me in tenths.
Mhm.
So then if you don't remember, hang on, how can I write it here real quick?
oh,
Okay. How like decimal placements, pretty much how you have your ones, and then you have that decimal point, and then you have your tenths, and then you have your hundredths. So pretty much all it's asking you is which one of these is given to you in tenths, because it's telling you that that's how the graduated cylinder measures. So then the only right answer for that bit would have to be the one that has 5.4, because that's the one that follows the measurement of the graduated cylinder.
And then if you guys were choosing D, you're not wrong. D is the most what is it
Accurate.
for? Accurate measurement. But our graduated cylinder is not equipped to make that measurement. So we can't choose that answer, because if you do 5.05, 5.405, people are gonna look at you crazy and be like, how did you measure the last 0.005?
Yeah,
Because
there you
there's
go.
no way for you to measure it. So the most accurate measurement that you can make with this graduated cylinder, like Brittany said, is the one with the tenths measurement, which is B.
all right. So kind of to clear things up, does anyone have any questions regarding like, just your specific measurements using specific numbers? Or like, well, I don't know why I keep splitting my significant figures. There we go. I know it starts with an S. Like anyone kind of confused, or maybe another example? Because I feel like as we go on, we'll start seeing more and more of it. All right, I'll take your silence as a no. All right, so moving on to number 5. Here it's asking us like how many, so it's asking us for how many kilograms are there in, so we're given 5.6 times 10 to the power of 7 nanograms. So this is the current mass that we have, and we're trying to look for kilograms here. So what can I do first in order to convert my nanograms to kilograms? Like, what's the first step I could do?
We could start by turning it into grams first.
So let's start with that, right? So what's the conversion between grams and nanograms? Like, what's the ratio between them? Like, say, how many like grams do I have for every nanogram?
Is it 10 to the power of 9?
10 to the power of -9. Remember, because if you remember your, I believe like the little chart showing the suffixes for units. So I'm just going to start at our base here, where we go from base to so milli, centi. I mean centimilli. My bad. Milli. What's it? I'm trying to remember the acronym. So like, thank God, man, King Henry died drinking chocolate milk. Oh yeah, so it's centimilli, and then micro. Well, that's not micro. Micro, nano, pico. So if pico here is like to the power of -9, because we're going backwards, right? Because it's like almost multiples of 3. So for every 1 nanogram, there's 1 times 10 to the power of -9 grams. So we have our first conversion right there. So let's work it out. So here we have 5.6 times 10 to the power of 7 nanograms. And which of these numbers, like which goes at the top and which goes at the bottom?
The 1 nanogram.
So 1 nanogram will go at the bottom, right? So we have 1 nanogram, and since it's a ratio, either the top or bottom will be flipped. We have 1 times 10 to the power -9 grams, because that's the unit we're trying to convert to right now. So here we would cancel out our nanograms, and we'd be left with grams. But is that what the question is asking for?
Asking for kilogram.
Right. So what do I need to do here? I need to convert grams to kilograms. And what's the conversion ratio for that?
1,000 grams to 1 kilogram.
So for every 1,000 grams, there's 1 kilogram, right? So I would cancel out my grams here with the 1 kilogram at top, because that's what we're looking for. Cancel out the grams. And since we now have our final desired unit, we can now multiply by the top and divide by the bottom. And who can tell me what number does that give us?
Is it 5.6 times 10 to the negative 5 kilograms?
And what is my unit?
Kilograms?
Yeah, kilograms. So 5.6 times 10 to the power -5 kilograms. Yes, this would be your final answer. So good job. So with that being our final answer, let's move forward. So if anyone has any questions, feel free to interrupt me. So moving on to number 6, right? Now that we've handled conversions of units pretty well. Right now it's conversion of still with temperature units this time. So if we look at number 6, it's saying that you want to bake a cake for your friend's birthday. The recipe says the temperature of the oven must be heated to 450 Kelvin. Your oven only has temperature settings in Celsius and Fahrenheit, so you convert temperature to the previous 2 temperatures respectively. So you can, sorry, I don't know, this worded weirdly for me. So you convert the temperature to the previous 2 temperatures respectively. Oh, I see. Yeah, so you're given 450 Kelvin, and it's asking you to convert to degrees Celsius and to degrees Fahrenheit. So who can tell me how can you convert from Kelvin to Celsius, first of all?
Subtract 270.
Oh, you cut out. Can you repeat that?
Subtract by 270.
Yeah, I get what you're trying to say. You cut out again, but I get what you're trying to say. Yeah, you would subtract your Kelvin from 273. And so, what number would that give me?
$177.
Yeah, 177 degrees Celsius, because how we convert to Celsius. Now for Fahrenheit, how can I convert my temperature to Fahrenheit now?
Would you add or subtract 32 degrees Fahrenheit times 9/5, or is it 5/9? I always get confused.
There's actually a little formula here. Let's see if I can, because like we hardly like ever use this formula, but let's see, it should be in your workbook actually. Let's see here, it should be somewhere in your workbook. But basically it's like a really weird equation where you have to like use a fraction and all that.
I have degrees Celsius plus 32 degrees times 9/5.
Yeah, there we go. So plus 32 degrees. Was it Celsius plus 32 plus, what was it again?
Times 9/5.
Oh, times 9/5. Yeah. So let me double check on that. Here, this is all kind of weird. Actually, it would. Let's see here. Yeah, that would technically would it?
Yeah, Alan.
Yeah.
So he's correct with using the fraction because it's similar to multiplying by 1.8, I believe, is
Yeah.
the actual number. So when going into Fahrenheit, you use 9/5, and then when you're going into Celsius, you would subtract the 32 and then multiply by 5/9 instead of 9/5.
Yeah, there we go. Like when I saw the fraction, I was like kind of confused because I remembered by the number. Yeah. All right. So yeah, good job. So if that's the case, we would take our Celsius that we converted, so 177, add it to this multiple here, and what would that give me?
Uh, 376.
370. Yeah. So this will give you 376 degrees Fahrenheit. So now, so I know like the side-by-side options are in your book here. So in this case, your answer, if you're looking at your book, would be C, because it gives us 177 degrees Celsius from our conversion, and then 376 degrees Fahrenheit for some conversion to Fahrenheit. So yeah, so your final answer would be C on that review question. Typically, you should probably expect like one Fahrenheit conversion thing, problem, maybe. Like you just typically don't really use it, but just keep that in mind. So going on to the last problem of page 296, number 7 here. We see that we're given like a chart here. So it's giving us a list of students where there are lab partners for a lab, and they're asked to conduct experiments independently. They were each supposed to take 15 milliliters of water and weigh the mass of the volume of the water, and it was repeated 3 times. And then their measurements are there. So I'm just gonna quickly write it up here. So we have the first measurement, the second, and the third. And I'm just gonna write the first letter of their names. So we have Jamie, Philip, and then Mariana. So here, Jamie first measured 14.9 grams, then 14.5 grams, then 15.1 grams. Philip measured 15.9 grams, then 15.8 grams. Let me fix that 8. And then 15.9 grams as well. And then Mariana measured 14.5 grams, 15.0 grams, and then 13.0 grams. So out of the 3 students, given like which one had the highest precision? Because they were supposed to measure 15 grams of water. So which one had the highest precision?
What is precision?
Yeah, there's a big importance, because you may confuse precision with accuracy. P. Philip. So why do you think so let's see, who was it that answered in the chat? I need to check again.
I think it was Christopher.
Christopher, yes. So why do you think it is Philip that was more precise?
He says the results are more precise but not accurate. Someone else is thinking it's J.
So more precise but not accurate. So you are right with that explanation right there. Where remember, so the definition of precision is how close each of your trials are to each other. And accuracy, precision is how close you are to the true. Even I get them confused. Sorry about that. Yeah. Let me double check on it.
Precision.
Oh,
precision. Yeah, they're going. Yeah.
Precision is regardless of what number you get, you want to make sure that they're kind of as close to each other as possible, regardless if it's the right or wrong answer. Just as long as you get close to the same number every single trial.
Yeah, that's what it was.
And then accuracy, which is actually going to be the next question right now, that's how close you are to what you actually want. So then between these three, it looks like Philip does have the highest precision because his trials are pretty much like close to each other. There's only one that's different, and it's by like a 0.1 gram. So then his are the most precise. So then you're going to be choosing answer A for this one.
Yeah, because it is, even for like us peculiars, like some of these little mundane things can get confusing from that time, which is very important for you guys to remember that difference. So let's see, someone asking in the chat. Yeah. So just remember the difference where precision is how close each of your answers are, and accuracy is how close your answers are to the true answer that you're supposed to get. So
Can you leave this bit up for the next
oh,
question?
sorry. Here, yep. Here, let me undo that.
There we go. That's fine.
There it goes. So whoever's up next can take the lead.
Okay, so then now we're gonna move on to talk about accuracy. So we said how precision was the ones that are closest to each other, and then now we specified that accuracy is the one that's closest to the actual value. So then between these three, you can kind of eyeball it, but if you're still not 100% sure, you could take the average. So let's go ahead and try that out, whether you decide to eyeball it or actually do some math on it and decide which one is closer to 15 grams overall. What do we think?
Would it be Jamie because her values are like 5 or less, I guess like 0.0 grams away from 15, and everybody else is above?
Yes, so then if you look at Jamie, they have 14.9, which is pretty close to 15, and then there's 14.5, and then there's 15.1. So really the only one that's kind of like more off is that middle one, but the ones on the side make it kind of pretty close to 15, right? Okay, so then now for the next one, which student had the highest % error? So then for this one, we want to kind of figure out which one is like off. You know, which one's kind of like the least right. Let's put it that way. So then how would we go about that?
How would we know which is the most right?
There we go. That's a good place to start.
By taking the average?
Okay.
Yeah.
Oh,
So we start. So yeah. So let's start off with that by taking the average of all their trials, right? Of Jamie's, of Philip's, and of Mariana's. Like take all their averages and see what's different about them.
Does everyone know how to take an average? It's completely fine if you don't. That's why we're here.
You add all their values and divide it by the number that how many values there are, right?
Yeah, there you go.
Exactly.
So for Jamie, I got 14.83, 14.86, and Mariana 14.16.
14.16. Okay, so then now from those, kind of ties in back to accuracy, except that now instead of the most right, you're looking at the most wrong. So then what are we thinking?
It'd be Mariana then, no? He's the furthest away.
Furthest away?
Well,
Okay, so how far away are they each from 15?
well, Jamie would be just shy of it by 0.2.
Okay.
And then, who's the second? Philip, right?
Mhm.
Philip is over it by 0.8. And Mariana's behind it by 0.9. She's short. Okay.
Alrighty, we're getting on some confirmation from. Okay, because wait, hang on. The averages we got were. Say them again.
14.83 for Jamie, Philip 15.86, and Mariana 14.16.
14.16. Oh, final consensus. I know we're having some bit of discourse on our end, I think. There you go. Jeremiah's typing away.
So if our goal is to get as close to 15 as possible, who got the closest to 15?
But then
She
highest
means the
percentage error is
opposite.
the one that's further off.
Yeah.
So we're gonna go ahead and go with Philip.
Or are we doing number 9?
Yeah.
Oh,
Okay.
I thought we were doing number 8. I'm sorry.
Okay, that's why I was like, oh my goodness, we're having a little, okay. Anyway, moving on. It should be Philip because he's kind of like further away. Jeremiah pretty much typed in a little summary up in the chat. Okay, so then now moving on to our best friend, dimensional analysis. Let me go ahead and clear this out. Okay, so then this one says, Annie caught the flu this winter season and ended up in the hospital. Oh no, it sounds a little familiar. She overheard the doctor tell the nurse that she needs to intravenously administer 0.9% normal saline at 15 drops per second. The IV machine operates at milliliters per minute. What number could the nurse need to input the IV machine to properly administer fluids to Annie? And it gives us a conversion factor of 20 drops to 1 milliliters. Okay, so then we have the information that we need 15 drops per second. So 15 drops per 1 second. And we want to find out milliliters per minute. And then we also have that extra 0.9% in there, but do we really need that? Probably not, right? It's not going to help us in any conversion. So we're just going to drop that 0.9%. So then from here, what conversion factors can I use to get from drops to milliliters and seconds to minutes? What do I know? What am I being given?
Well, you're given 20 drops is 1 milliliter.
Okay, so we're gonna go ahead and excuse me, add that to our fence. 20 drops equals 1 milliliter. So do my drops go at the top or at the bottom?
Bottom.
Bottom, right? Because we want them to cancel out. 20 drops, 1 milliliter at the top. And that's going to give me the milliliters I need. Okay, so then that gives me milliliters. Now what do we do to convert from seconds to minutes?
60 seconds is 1 minute.
60 seconds is 1 minute. And which one goes at the top or at the bottom? Where do my seconds go?
Up top.
Okay, up top. There we go. 60 seconds, 1 minute. So then right here, after I cancel out the units that I have the same, which is my drops and my seconds, I should be left with milliliters at the top, minutes at the bottom. And at this point, you know the drill, multiply the top, then multiply everything on the bottom, and then divide them by each other. and let me know what you get.
$45 milliliters per minute.
45 milliliters per minute. Do we have someone else second this?
Yeah.
Okay, so then now from there, it looks like we can go with answer A. All good on this. No questions. Super simple, right? We're all experts at this by now. That's why we're here, to brush up. Okay, so then now moving on to number 11, still using conversions. Let me go ahead and clear this out as well. It's telling us the average height for females in the US is 5.333 feet. What would this measurement be in centimeters? And they're nice enough to give you the conversion factor. However, they give it to you from centimeters to inches. So if we're starting off with 5.333 feet, what do we want to go ahead and do so we can use that conversion factor given?
Convert feet to inches. And then
Convert feet to inches, right? And what do we all know the conversion factor for this? What is it?
12 inches in a foot.
12 inches in a foot, and then which one goes at the bottom?
Feet.
There we go. 1 foot, 12 inches. I know you guys are probably like bored of us saying which one goes top or bottom every time, but you'd be surprised how many people still need to remember this. Okay, so then that's gonna convert us to inches, and then now from inches to centimeters.
Use the conversion given, which is
The conversion, right? 1 inch equals 2.54. So same drill, inches at the bottom so you can cancel out. 2.54 centimeters at the top. And cancel out inches. And this one, since the bottom numbers are just 1 times 1, it's kind of redundant to do the bottom. So then just multiply all across at the top. Let me know what your answer is in centimeters.
162.5.
162.5. That is correct. And therefore, we should be picking letter choice A. Okay. Any questions on these past 4 problems? Stay silent for no. Okay, cool. Yes?
But would significant figures matter, or would the question specifically state that?
The question will specifically let you know.
Okay.
What to use. So if they don't ask for significant figures, just try to pick the one that's closest to the answer you actually get.
Okay, thank you.
Awesome, sounds good. Okay, I think now we're gonna be able to turning it over to Mr. Jeremiah. Is he in the building?
Yeah, I'm here.
There we go.
All right. It's 18, right? Not crazy.
12?
12.
Oh, did I write 12? I meant 17. Brittany.
Oh, so I keep going. Oh,
Yeah.
my bad. That's my fault. My brain just wants to leave. It's okay. Okay, so then it looks like it's back to me. Okay, so then for number 12, it tells me an architect was asked to design a cube house with a square footage of 1,500. What are the dimensions, length, and width he must use to build this house in? So then we'll start off with our given. So 1,500, and it's telling me that that's square footage. So what's my unit?
Feet squared?
Feet squared, right? You just take away the AGE at the end. Okay, so this is feet squared. And they want me to find the length and the width. So let's say that this is the thing that it's in. That's my house. Well, actually, it should be a cube. Pretend this is a square. It's okay. This is chemistry, not art. And we want to find the length and the width of this cube house. So then this pretty much just takes us back to math. So then what would you go ahead and do to this 1500 to figure out length and width?
We take the square root of it. Or...
Just take the square root, right? Because it's a cube and therefore both lengths should be the same. You're gonna go ahead and take the square root, and that's actually gonna get rid of my squared unit. And what should we get in feet?
I get 38.7298.
0.7298. Is that it?
Yeah, that's the only numbers it gave me.
Okay. So then, does it look like it's any of our answer choices?
No.
No, right? There's one that's like 35.4, but that's still kind of a little bit offish. It's probably going to give you a way different number. So it's gonna probably have to be the ugly answer choice that we all despise to see, none of the above for this one. Okay, so then that one, just a little math to get you a little break from the chemistry stuff. Now we're gonna dive into the good stuff. So then for number 13, they're asking me for a compound form between a lithium ion and a sulfide ion, and they want us to find the formula for it. So what do I know about a lithium ion and what do I know about a sulfide ion? How do I write my lithium ion to begin with?
Isn't it Li plus?
Li plus. There we go. And what about sulfide?
I know it has a negative, but I just forget what number it has.
Okay, then that'd be the perfect time to go look at your periodic table and let me know the charge like based on the group it's in.
S2 minus charge.
S2 minus, there we go. Because it's in group 6, so it should have a charge of 2 minus. So now to go ahead and find out my formula, what do I have to do here now that I know the charges?
Well, when you combine ions, don't the superscripts go into opposite subscripts?
There we go. So we want to go ahead and cross them over, right? So if this is supposed to be a +1, I'm going to go and move it down here to the S. This one's going to move down here to the Li. So then what should my name be for this compound? Li.
2S, sorry.
Yeah, you're good. Li2S, right? And that leads me to pick answer choice B. Okay. So far, so good on this one? Don't get too excited. Okay. So then now for number 14, this is more conceptual and it's letting me know that if an element belonging to the alkaline earth metals were to form a compound with a halogen, this would likely be what type of compound? And of course, you have to select the best answer. So then I have my alkali earth metal. They're pretty much telling you it's a metal. And my halogen, what type of element is it? Is it a metal or a non-metal?
Non.
It's a non-metal, right? So then if you have your alkaline earth metal, and then your halogen is a non-metal, and you combine these two, what type of bond are you going to get? You have either ionic, covalent, metallic, molecular, or not a compound.
Ionic.
Ionic, right?
Ionic.
They're going to have different charges, and once they come together, they're going to be united by that charge. So this would be answer choice A.
Another way you can choose the right answer if you are extremely lost and you don't know what's going on is, okay, first of all, how many types of compounds do we know about in chemistry so far? Anybody?
It comes after 1.
Two.
Yes, 2. So what are the two, sorry, what are the 2 types of compounds that we know about?
Covalent and ionic.
Ionic and
Covalent and ionic, right? So is C even a possible choice?
No.
No, right? And then covalent bonds have another name. Does anybody know what the other name for a covalent bond is?
Molecular.
Yeah, molecular. And so then that means that B and D are the same answer. So can't be that one either, right? And we know for sure it's a bond, so guess what? Your answer is A. Anyway.
There you go. Process of elimination. We love that. Alrighty. So then now moving on to number 15. We're working with nomenclature. They're asking me to name the compound at SF6. So first off, if you don't know where to begin, your first step would probably be, okay, what kind of compound are we talking about? Is SF6 ionic or covalent?
Covalent, right?
Yes, it is covalent. So then now having this in mind, what are my naming rules for a covalent compound?
the prefixes.
There we go. That's our keyword right here. When you have a covalent, you want prefixes. So then we have 1 sulfur and 6 fluorines. So then what are we going to do with these guys?
We would give them prefixes, right? Well, I know the F6 is hexafluoride,
Okay, hexafluoride.
but I forget whether you give the first element a prefix or not.
Okay, so then for hexafluoride, remember you also have to have "ide" at the end. So now let's help out Tony. Do we use prefixes for the first element?
Not if it's mono, right?
Exactly, not if it's mono. So if you only have 1 of them, you don't have to worry about a prefix. So then in this case, what would we just write for that first word?
Sulfur.
Just sulfur, right? So then it's good that you're in here to ask that, because now we've got that cleared up and you've got probably a couple extra points on your exam. So again, remember with covalent, use prefixes, except if the first element is only 1. No mono. If you were to have just 1 single element as your second element, then you could include mono, but not if it's the first one. So then in this case, it's just sulfur hexafluoride, and that would be answer choice D. Okay.
Would that same rule apply for ionic compounds, or?
For ionic compounds, do we use prefixes, guys?
No, the second one.
There we go. So now when you're working with ionic compounds, we don't use prefixes because the charge already tells us how many of each element we're going to have. When it's covalent, you can have pretty much whatever amount. So then that's why we have to include prefixes so we know how many to include.
Okay then.
But yeah, good questions. We love questions. So covalent, prefixes, ionic, no prefixes. Okay. Number 16. keep forgetting to like number them. Okay. Which of the following is a proper chemical formula or chemical name? Okay, so then it looks like we're gonna kind of have to like go and check which ones are written appropriately and which ones aren't. So then for the first choice, we have KNO3. For the second one, we have calcium 2 chloride. That's an I, by the way. For C, we have Mg2 and 3. For D, we have K2PO4. And for E, we have none of the above. Oh, no, wait, all are correct. Sorry, I was reading number 15. And we're trying to look for the one that is proper, that it's true. Okay, so at this point, you're probably experts at it. So if you haven't answered, go ahead and give it, but we're still gonna go down the list and saying why they're right or they're wrong. So then for letter A, we have K and NO3. Is this an appropriate way to write this compound? What do we think? KNO3. Have we seen KNO3 before? Okay, Elizabeth is saying yes. So pretty much if you don't know where to begin, go ahead and look at whether there are charges involved, whether it be ionic, covalent. So then what do we know about potassium and what do we know about NO3?
Potassium has a +1 charge and nitrate has a -1.
There we go. So then if you put them together, they balance out pretty nicely and they'll be able to link via ionic bond. So then so far it looks like this one is a proper way to write that. Okay, so then now if we're taking this one into consideration for our answer, let's dive into answer B, which is calcium 2 chloride. Is this a proper way to write this one?
No, you would only use the little like I's when it's transition metals.
There we go. So then Roman numerals are only for transition. So then since calcium isn't a transition metal, so then we can't use the Roman numerals here. So then we're gonna go ahead and get rid of this one. What about Mg2N3?
No, it's not balanced.
It's not balanced correctly, right? It looks like what they ended up doing here instead, they did the 2, instead of using it as a charge and crossing it over, they just kind of sunk them down instead of crossing over. So then this one cannot be it either because they didn't cross over. What about K2PO4?
Potassium has a 1+ charge and PO4 has a 3- charge.
There we
So
go.
they're, I think, missing a.
So it's missing a potassium, right? The proper way to do it would be to write K3PO4 instead. But we are missing a potassium, so this one is not balanced properly either. So then we can go ahead and get rid of this one. And since we pretty much already found 3 errors in our answer choices, then there's no way that all of them can be correct, right? So we're gonna go with answer choice A. Okay. No questions so far on anything? Okay,
No.
looks like we're doing it. Oh, I think I heard a peep.
I'm sorry, I said no question.
Oh, okay. Okay, we're good. We're just refreshing what we learned at the very beginning, right? Okay, so then number 17. It's going to ask about polyatomic ions and oxoanions, so pretty much your rule of 7. This one asks, the polyatomic ion phosphate contains blank oxygens and has a charge of blank. So we're talking about phosphate. How many oxygens? And what's the charge? So we're thinking rule of 7. So then how do we go ahead and determine number of oxygens to begin with?
Well, since it ends in 8, I mean, and it's what's it called? It's in the little middle part. So I think phosphorus, sulfur, arsenic, and selenium. We would have 4 oxygens.
Right. So then since it ends in 8, we have to use the reference number for the square, which is 4, right? So far we're off to a good start. 4 oxygens. Oh, there we go. I'm barely reading the chat. And Elizabeth also says that it should have a -3 charge. How did we find this -3 charge? You just I think y'all are just being shy, but I'm pretty sure you would look at your periodic table and then just follow the groups, right? So then from there, you kind of like count backwards, starting with group 7, so 1, 2, 3, and then that should be your -3 charge. So then that leads us to answer choice D.
Can you repeat that about the 4 oxygens?
About the 4 oxygens? Awesome. Okay, we can do that. Okay, so then for rule of 7, I don't know if you remember, let me see if I can draw it out a little, like the periodic table. We have the elements C, N, O, F, I think B as well. And then down the list, we have Cl, Br, I, and then in the middle, we have phosphorus, sulfur, arsenic, and selenium. So then this ties in back to the rule of 7 that we learned at the beginning of the semester. So then pretty much this outer portion out here that looks like a 7, that's why we call it rule of 7. It kind of like splits off into 2 pieces, the 7 part and the little square part. So then from here, if you're part of the 7, we have what we call a reference number of 3. And if you're part of the square, we have what we call a reference number of 4. So this is pretty much like where you're going to begin counting. So then for whether you're in the 7 or where you're in the circle, in the square in the middle, if your suffix is 8, you're going to use whatever reference number is assigned to the area that your element is in. And then if you lose 1 oxygen, yeah, there we go. Someone's referencing page 62 of the workbook. We have like a nice little chart up there. If you lose 1 oxygen, what does my suffix become? There we go, ite. And if you lose another one, if you lose 2 oxygens from your reference number,
Hypoite.
Hypoite. And oh, see, that's also a nice way to put it. Diego is saying, look at how the reference number add up to 7. You can also remember the oxygens that way. It's like rule of 7. And then there's also, if you add 1 oxygen from your reference number, what should my prefix and suffix be?
Ide.
Plus 1 oxygen?
Is it?
Is it?
Is it per and 8?
There we go. Per and 8. So then again, you have to pretty much identify what part of the rule of 7 your element is in. So right here, we're working with phosphorus. So then it's inside the square. And since it ends in 8, we have to go ahead and use the reference number as our number of oxygens. So since we have reference number 4, we have 4 oxygens. Does that make sense?
Yes, thank you.
Okay, but yeah, if you want to study it a little bit more, Elizabeth referenced page 62 of the workbook, if you still have any questions on that. Okay, and then lastly for me, my voice already getting kind of hoarse. For number 18, we're asked to identify polyatomic ions that all have 3 oxygens and a charge of -2. And all of them have to have that. So they have to have 3 oxygens and charge of -2. So then we have answer choice A. We have chlorate, sulfite, and carbonate. What about carbonate? Because I see in the chat carbonate question mark. We have to make sure that all 3 answers have 3 oxygens and a charge of -2. So do all of these follow that rule? Yeah, carbonate does follow it. So good on that. But what about chlorate and sulfite? Do chlorate and sulfite follow this rule? 3 oxygens, charge of -2. Just as long as you find one odd one out, you can get rid of the entire answer. What do we think? How many oxygens does chlorate have? Or what are my formulas for this?
So sulfite is right because it's SO3 2 minus.
Mm-hmm.
But chlorite is wrong because it's ClO3 minus.
And it only has a charge of -1, right? So since this one's wrong, we get rid of the entire answer. So then now for B, they give me carbonate, selenate, and chlorate. What about this one?
Carbonate is right, but selenate has 4 oxygens, I think.
Selenate has 4 oxygens. Okay, so then this one kind of breaks the rule. And does fluorate even exist? Probably not, right? Because anytime we do a rule of 7 and like we assign the charges, we always skip over that F and then we start counting it at. We skip F, we skip O, and then we start counting at the others. Okay. So then, because we know that this one's wrong, at least for sure, you can go ahead and get rid of the whole thing. And then now for C, we have phosphite. We have selenite. We have sulfite. What about this one? In the meantime, I'll go ahead and write the last answer.
Phosphite has a 3 minus charge.
Phosphide has a 3 minus charge, right? So then we found the odd one out. We can go ahead and get rid of the entire thing. D gives me carbonate, selenite, sulfite. What do we think about this one?
They all have 3 oxygens and a 2 minus charge.
Okay, so then it looks like they all have 3 oxygens and 2 minus charge. So CO3 2 minus, SeO3 2 minus, SO3 2 minus. So then we're gonna go ahead and go with answer D. Any questions on any of this? No? Okay. Now I can go ahead and turn it over to Jeremiah. I was getting a little bit ahead of myself with the last one. I think I actually even did one of his. I'm sorry. I got a little carried away.
You did, but you seemed like you were excited, so I let you go for it.
Okay. I'm sorry.
Wait, before you keep going, let me stop the recording and then start it over. Hold on.
Okay.